So, the very first type is going to be a decimal, and it's going to be called a terminating decimal. Okay, and that looks like this, like 8.5 or 3.3. 6, we say. Okay, thanks.
Yeah.
Okay, so that's one type, a terminating decimal, means the decimal ends. So you could say like 8.5 or $8.50, 3.36, it terminates, okay? What terminate means is the decimal doesn't go on forever and ever, okay? And I don't expect you to remember all this, that's why I said just write it down, because you can use this on your test or quiz. So make sure that you write good notes today, and then I'll keep it for you until you take your test. Okay, the other type is gonna be a repeat decimal.
I hate being sick.
Okay, a repeat decimal maybe looks like this, 8.6, or it looks like 8.33333, and it keeps on going for a long time. Okay, so do you notice the difference between a terminating and repeating? Like, can you tell?
Yeah.
Okay, so you need to be able to tell. Okay, and then the third type of rational number is going to be a fraction. Okay, 1/2, maybe 5/2. So these are all rational numbers. But those are the three main types that you're going to see, okay? So, when we go down, so if you look at this box, okay, see how there's a little tiny box, and then the box gets a little bigger, and then the box gets a little bigger, and it gets a little bigger, yes? Okay, so the very inside box, okay, the natural numbers, these are all positive numbers. They're all positive.
You almost said to me what?
Okay, what about whole numbers? What's the difference between natural and whole?
Got a 0.
One's got a 0. Okay, so these are all positive. And it has 0. Okay, what about integers?
Negative.
It's got negatives on there too. So it's got all positive. It's got a 0. And it's got negatives. Okay, which means rational then are all positive, 0, negative, decimals, and fractions. Okay, so each time that our box gets bigger and bigger and bigger, it adds more things. Okay? Now, I know this probably feels like a lot, and you're probably like, I don't know what the heck is going on. You shouldn't yet, okay? I never got the concept of this, and you're like, we did this last year. And most people probably don't get the concept of it. I didn't until I was in college, and one day I snapped and it clicked for me. Okay, but I never got it before then. Okay, now, and then we're going to talk about irrational numbers. So irrational numbers like pi, the number pi is 3.14. Okay, but the number actually keeps going. It's like 6, 9, 8, 2, 3, 4, 5, 6, 7, 8. Okay, and what happens is see how this one, it terminates 8.5, it stops right there, okay? Or it stops at 3.14, it stops if it's a terminating. Repeating, it's the same number after the decimal. What makes something irrational is because the number never stops and it keeps changing. This keeps going on forever and ever and ever, all the way around the whole school, it keeps going on. And the numbers aren't the same, it just keeps changing and changing. First it's a 1, then it's a 4, then it's a 6, then it's a 9. Okay, so irrational numbers, the decimal never stops or repeats. Okay, and so that's how we can tell. And actually, where's my phone? Okay, so if you look at a square root of 2, the number is 1.41421356237309. And so even though it looks like it stopped on my phone, it didn't actually. Okay? My phone doesn't go on forever and ever, so it had to stop somewhere. But the number doesn't stop right away, and it keeps changing after the decimal point. So that's what makes something rational. Okay, so I just want you to look at this sheet, okay, and I'm going to list off some numbers, and you're going to tell me what kind. Okay, when we look at these, we always start on the inside box, so on this natural number box. So if I were to give you the number 4, okay, is that natural? Positive 4, is it natural?
Yeah.
Okay, yes. Is it a whole number? Look at your sheet. What you looking at me for? I just named off a number.
It's all,
Huh?
yeah.
Yes. Is positive 4 an integer? Look at your sheet. So just because it's not on there, right, because you don't see a positive 4, it is. It's still an integer. Remember, our integers are all positive numbers. Okay? So the way that this chart works, look up here. If as soon as we say yes, yes, it's natural, then the rest of them have to be true. Yes, then it's this one, yes, yes. Okay? So if I said the number 3, is 3 a natural? Is 3 a natural number?
Mm-hmm.
Yes. So as soon as I say yes, then my answer is yes, it's also whole. Yes, it's also an integer. Yes, it's also rational. Okay, what about 0? Is 0 a natural number?
No.
No. Okay, is it a whole number? Yes, which means yes, it's an integer. Yes, it's rational. As soon as you say yes, everything above it is a yes. Okay, that's where we start from the inside box. What about the number -1? Is it natural?
Nope.
No. Is it a whole?
Nope.
Is it an integer?
Mm-hmm.
Are you with me? Because you look like you're zoning out. Okay? Yes, it's an integer, and so then yes, it's rational. Okay? Okay, 1/2. Go to your sheet for real. And I'm sorry because you're going to have to kind of flip back and forth. Actually, I have some of these you guys can use. Let me go get one. 1, 2, 3. That way you can look at the chart at least. You don't have to flip back and forth. Okay, 1/2. We start on the inside of the chart. Is it natural?
No.
Okay, 1/2. Is it natural? Look at the inside of your chart. Is it a natural number?
What number you say?
1/2. Well, we're looking at number 1. But the number we're given is 1/2.